Okay, here we go. Episode 2. And it looks like we got a lot of stuff with graphing and their attributes. Okay, so one of the things that we're going to go ahead and need for this adventure is our graphing calculators. And we're going to learn some skills about, how to go ahead and get minimums and maximums and some other good points of our graph. So let's take a look at the things that we're going to be able to do once this is over. So can I identify when a function is increasing, decreasing, or constant and use interval notation to state it? How do I go ahead and use a graphing calculator to find minimums and maximums of graph? How can I determine if a function is even or odd? And what is the rate of change of a function? How do I calculate it? And then we're going to be moving from rate of change on over to some position, velocity, and acceleration type applications with it. So let's see what else we got. Okay. And so here's some of the key vocabulary that we're going to go ahead and be looking at here is that we're going to look at relative maximums and relative minimums. Okay, so those are going to be where a turning point of the graph that is going to change from this business of increasing, so it would increase like this, on over to decreasing in this direction. Okay, so that's what would make a relative maximum, going from increasing to a decreasing graph, and likewise with a relative minimum going from decreasing to this business of increasing. Okay, and something that we want to go ahead and also make sure that we have down is that there is part of a graph that is going to be constant as well if it is just going to be your horizontal line. Okay, and so that means is that no matter what value you put in for x, the output is always going to be the same. We're also going to be looking at and trying to determine, using algebra and using graphs of functions, this business of even and odd functions. Okay, and so we're going to find out that even and odd functions are going to have a definite rhyme and reason to them. First of all, is that an even function is going to be symmetric to the y-axis. Okay, so even if you made this into like a little face right here, right, something like that, you know that it would be symmetrical. So if there's one attribute over here, then there's going to be another attribute over here, and the same thing with the points. And so if it looks like I'm going to have this guy right here, 1 1, then I would count on over to this side and reflect that guy to have a 1 or a negative 1 1. Okay, and so we're going to take a look at how to test for those a little bit later. Okay, and we're also going to take a look at this odd function, which is going to be something that is a function that is symmetrical with respect to the origin. So that means basically if you have a point here and a point here, it is going to kind of create like these little bit of stairs, if you will, through the origin to the next point, where this length right here and this length right here would be the same, and this length right here and this length right here would be the same. So we're not going to get too far into it with just the vocabulary, because we're going to delve deeper into it later on. So let's go ahead and get our graphing calculators ready, and we need to look at this first example here of how to obtain the minimums and maximums and intercepts. Okay, so this is the function that we're going to go ahead and be going after with this business of our graphing calculator. Okay, so the first thing that we want to do is that we want to get the function plugged in, and then to our graphing calculator, and then get a nice window to view it. So let's do that. All right, so here we go, loading this function on into our calculator. So we're going to go to, I already got it loaded in where we got y equals, and then we're going to go a negative x to the third power. Okay, and go on over. So I'm going to try and do everything in real time with the calculator here rather than using any of my keyboard buttons. So it might take a little bit longer, but at least it will be complete and in instruction. Okay, so we got this this function right here, and as we started to talk about in class, what we want to do is that we want to go ahead and we start off with this business of zoom standard here, and the zoom standard is going to go ahead and bring up this type of graph where we're going to have, it's going to be 10 in the left direction, 10 in the right, and likewise 10 up and 10 down. And so if we want to go ahead and make it look like the graph that we had on the other page, that means is that we'd have to adjust the window. So let's practice adjusting the window to where that it would represent the actual page that you see on your notes there. So you would have this guy would have to be a -3, okay? And it looks like going on over, we would have this being a 4, and then going down. And I'm counting down, let's see how many here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it looks like a -10, leave it as is, and it looks like 5 up. And so we go 5 up, and then hit enter, and then we can graph that guy again, and you can see we have a nicer identical looking graph to what we just we have there on the page. So let's go after this minimum value first. Okay, so let's go ahead and get that minimum value here. So what we need to do is that we need to go ahead and we hit second and calc, and that's going to bring up an option for us to kind of go into this find the minimum mode. Okay, so we go down to it, and we can hit enter, or we're going to hit number 3, and it's going to bring up the little blinky guy. And what we want to do is that we want to, it says the left bound, we want to put the little blinky guy somewhere on the left hand side of where we suspect this minimum is going to be. So we know that the minimum is going to be somewhere in here. But the left bound, okay, is going to go ahead and basically when I hit the, again, blinky guy to the left of the minimum, when I hit enter, it's going to set up a line. So, and you notice it kind of like puts an arrow there, says, okay, I'm going to start looking here for a minimum, and then we go to the right hand side of that, and anywhere on the right hand side, and we hit enter again, and you notice that it sets up kind of like some search parameters that are going to be in between those two dotted lines. And then to aid the calculator in its quest for this minimum, we want to put it as close to where we suspect the minimum is going to be, and we hit enter. Okay, and it looks like we have a minimum value of a -1, comma -7. Now for this guy right here, we have all these zeros right here, and this sometimes will happen. It might not go ahead and perfectly land on a minimum X or a minimum Y value perfectly, and when it has something that is obviously that we would round up to a -1, this is how we would leave it be. And sometimes it just returns a nice integer like this -7 here. So, all right, looks like we got the minimum, and so let's record that on our paper and go after that maximum. All right, so let's go after that maximum point. So the maximum point, it looks like it's going to be somewhere in here. So let's call up the program part that says, hey, let's go after the maximum. And so we're going to go ahead and have the little blinky guy appear again. And we want to put little blinky guy to the left of where we suspect that this maximum is going to be at. So I'm going to, it looks like that's a pretty good spot where it just kind of appeared. And then go to the right bound of where we believe it's going to be. Okay, and so you notice that the maximum here is going to be in between those two dotted lines there. And so therefore we want to guess or put the as close as the blinky guy to the maximum as possible. Hit enter. And it looks like we're going to have a maximum of, in this case, it's 0.999999932, but this is going to go ahead and be, we're going to round that up to 1. So it's going to be 1 -3 right there, okay? Again, when you have that repetition of 9s all the way out, then that basically means is that it didn't land on the maximum exactly, and the calculator does that through a least squares regression, and that kind of thing just happens. So we need to know when to round this up and say, okay, that maximum is going to be 1, right? Because that would round up to 1, -3. Okay, so let's record that. And let's find that x-intercept. Okay, so now it is time to go after this x-intercept here. So we're going to have to go second and then calc, and then we're going to brighten up this function 0. And if you remember from past classes, that zeros of a function are going to go ahead and be the x values that make the function go to 0. And so therefore, those are also the x-intercepts. And so therefore, we can use this function to find our x-intercepts. So let's do that. Left bound, I put it on the left-hand side. Here's where my x-intercept is, somewhere in here. I'm going to put it to the left-hand side of that guy and hit enter. And then I'm going to go ahead and put it to the right-hand side of where I suspect that x-intercept is going to be. And then notice that the x-intercept is in between the two dotted lines. I go on over to where I suspect it's going as close as I can get it. And it looks like I'm going to have a -2.279, taking this out to 3 decimal places because this is pre-calculus. So let's all agree that we're going to take it out to 3 decimal places. And then our y equals 0. Okay. And so that would go ahead and give us our x-intercept. And for the next part, we can just go ahead and introducing this function called value. And I'm going to go after the y-intercept with this one. And so I can just go ahead and hit enter for the value. And we know that the x value of any y-intercept is 0. So I'm going to throw that in there. Hit enter, and you can see that it brings up the y-intercept at 0, -5. Okay, so we have all the good stuff, the gross anatomy of this this graph, and these are basically the skills that you're going to need on your calculator to be successful in the next parts of this lesson. So let's get on over to them. All right, so there's all our logged information, all our hard work. And what we're going to go ahead and do is we're going to apply it now to some of these graphs right here. Okay, so what we want to do, and I'm going to do this not on film this time because it's going to, it'll be far too long then. But I want you to practice finding the minimums and maximums of these graphs right here. And you can see that these are going to be the functions that you would put into your calculator. So once you find those, just go ahead and put the coordinates right by them, or log them any way that you wish. And then you can compare yours against mine in a moment. Because what we're going to do is that we're going to use these to start talking about this business of increasing and decreasing intervals. So we need all the minimums and maximums of these graphs before we can actually start doing that. So have at it and check your answers versus mine. Okay, so these are the minimums and maximums that you should have discovered. And what we're going to do right now is that we're going to go ahead and use these minimums and maximums just like, there are peaks of mountains and, lowest points of valleys. And then you have all the other stuff that's going on in between that, such as if I were to read this graph going from left to right, we notice that just like a roller coaster, we'd be going up that graph, and then we would peak out, and then go down that graph, and then we would bottom out, and then we would go up again. And so what we're looking at is this business of increasing and decreasing intervals in that way or in that vein. So when you're reading a graph from left to right, the graph is going to be increasing, decreasing, or remaining constant. Well, in this case, we're going to go ahead and state these increasing and decreasing intervals in interval notation, and we do so by just using the x values only. Okay, so that means is that just the x values are going to be used in this interval notation. So let me explain. Is that starting from here, the graph comes from a negative infinity coming from this direction. And then it is going to be going up, 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 up until the x value, which is right here. Okay? So it is increasing from a negative infinity on the x's all the way to a negative 0.291. Okay? And then it is going to go ahead and be going down. All right. Now, something that I skipped over is that notice that I used here also a parenthesis. And I did so because when you're having, like at the very top of something or at the very bottom of something, you're not increasing or decreasing any. And so therefore we can't have that x value in the increasing interval package because it's just not doing anything there. Okay, it's neither increasing or decreasing. It just is kind of sitting on top of that relative max there. So going back to the minimum, which is what we started right here, so that means is that I am decreasing from that top point, the x value, and I'm decreasing all the way until this value right here, which is going to be, oops, I'm going to fix that in a minute, which is going to go ahead and be where the graph bottoms out. So I got to change that to a decimal point, not a comma. Okay. And then we notice that it goes back up again. And it's going to keep going back up forever in this direction. And so therefore, I end up with a union, and then the x value, 2.291, all the way to infinity. Okay? And so that is how we go ahead and we do out increasing and decreasing values. Okay? So let's go ahead and take a look at the second one here. Okay? And I'm going to explain it a little bit quicker. Okay, so looking at the increasing and decreasing values for this second guy right here, remember that we need to go ahead and just use the x values. And I like to go and kind of color coordinate the increasing and decreasing intervals so I don't get confused. All right, and so let's go ahead and dial this up. Let's look at the decreasing intervals first, because it seems like we start with those. So we're going to be going from a negative infinity, right, starting here, all the way to a negative 2, okay, not including the negative 2. And then we start decreasing again at this point right there, because it looks like we have that little tiny bit right there where it's increasing. So we need to do union and then negative 0.750 all the way to this business of positive 2 and not including it. And so for the increasing part, we know that we are increasing here from a negative 2 all the way to a negative 0.750 union. Okay, and then we would go positive 2 all the way to infinity. And so that's how we would do that. So notice that we have to go ahead and rely on our calculator skills of getting the increase. And we have to get the minimums and maximums, then use the x values and a picture of the graph to go ahead and be able to state the increasing and decreasing intervals. Okay, so what we're going to go ahead and tackle next is this business of even and odd functions. So I'll see you in that next part. All right, in this part, we're going to go ahead and take a look at even and odd functions, or neither. So we're specifically looking at the algebraic tests that are going to hold true. Okay. So one thing that I want to take a look at is this business of, we know that from our vocabulary that the even function is going to be symmetrical over the y-axis. Okay. But why does that really happen? And the answer is that if we look right here at these particular values, we got this negative 4, 0, and a 4, 0, is that we notice that whether the 4 is negative or the 4 is positive, it is going to go ahead and have the same output. And likewise, if I were to look down here at this point where I'd have 2, negative 48, and a negative 2, negative 48, it doesn't matter if the x is positive or negative, it's going to have the same exact output. So what this basically means is that the following: no matter if the input is a negative x or a positive x, okay, that every value or every output is going to go ahead and be the same. Just like if I plugged one more time in here a negative 4, let me highlight that, negative 4 into this function right here, I'm going to get a 0 out. And if I plug in a positive 4 to the same function, I'm going to get a 0 out. So it doesn't matter if it's f of x or f of a negative x, they will yield the same. So therefore, this is how we are going to check to see if, algebraically, if a function is positive or negative. So the first thing that we do is that we have our given function, and what we do is that we change the x to a negative x, and we do so for all of the other parts like that. Okay. So with this, we start to go ahead and break the thing down, is that we go, all right, well, this is f of a negative x, and so I know if I got negative x to the 4th power, so if it's negative and it's raised to an even power, it's going to make it positive. And likewise for this guy over here, right, we got the 16, and that's going to be a negative x to the 2nd power. That's just going to give us x to the 2nd power. So what we want to do is that we look and we say, you know what, that is the same thing as that. So therefore, I can take, since those are equal to one another, I can replace that, the f of x, with the red box there, and that is going to give me f of a negative x equals f of x, which completes our definition right here. So that's how we would algebraically check for an even function. For an odd function, it is going to go ahead and be it's like a same but different, if you will. Okay, so if I look right here, if I plug in and I'm just going to look at some points, plug in a positive 1, okay, into this guy right here, I get a negative 24 out. And if I plug in a negative 1 right here, I get a positive 24 out. So you notice that this is kind of like the pattern here: positive, negative, negative, positive. And the numbers themselves are the same, but the signs are different. And you can see that this is going to be the same with these other numbers right here. So what this means is the following, is that if I were to have any value for f of x, if I plugged in a negative x or the opposite of x, whatever it is, positive or negative, then I would get the opposite of y out. Just like if I were to go right here, the positive value for x end up being a negative value for y. Okay, but if I plugged in the opposite value, the negative value for x, I would get the opposite value of y out. So that's what we're checking for when we replace the x, okay, with a negative x. We're looking for the opposite of the said function. So this is how it works. We plug in a negative x, and I get a negative x to the third minus 25 times a negative x. So now I have to start cleaning things up. And so I'm going to get, keeping that side the same. So since this is raised to an odd power, I'm going to have, it's going to stay negative, and a negative times a negative right here is a positive. Okay. And so now I'm like, okay, well, how does this relate to this function right here? So we're going to, how does this and this relate? And right now it's just like, they're not exactly the same. But what I can do to make them the same and opposite is factor out a negative sign, like a -1 right here, and that will flip all of the signs in here like that. And you notice now I have the exact same in the parentheses, and I still have that negative sign, or the -1 out in front. So what I'm going to do is, like I did in the last one, I'm going to replace, since the two highlighted regions are equal, I'm going to plug f of x in right there. And at the end of the day, that's going to give me f of a negative x equals, I'll bring down that -1 and multiply that by f of x, and that completes my definition right here. Okay, and so that's how you test for even and odd functions, and why the test works. And it will take some practice to go ahead and get this thing down, but after a few tries it becomes second nature. So that's how you do that, and I will see you in the next part.